Welcome to another educational video for CSCI 1300. My name is Ioana Fleming and we are continuing our discussion about nested branches. Today we're going to learn about debugging and how debugging can help us follow the flow of execution of our program to see exactly which branches will be executed based on values of variables or input values from the user, for example. We were working last time on computing the tax rate for an individual, and we were following some directions where basically the tax rate for an individual depended on two things. One was the marital status. Was the person married or single? And second was the taxable income. So we would ask the user to enter the value of the taxable income and enter a character for their marital status. Then, basically, if they were single, they would follow the single limit income. So if their income was below $32,000, they would go in the 10% bracket. If the income was above, they would go in the 25% bracket. Same for if they were married, if their marital status was married. So this was the program we wrote. You can see that if and else branches, the main branches based on marital status, and then more branching here based on the taxable income. Today I want to introduce you to debugging. Debugging is a way to go through your program step by step, line by line, execute it just one line at a time, while at the same time watching how do your variable change. Does your program go exactly in the order that you intended? So it's very nice. We call that following the flow of execution. Debugging doesn't always mean finding a bug. I guess the goal is to find the bugs in your program, but it's also really good here in this example as a learning tool. So I have here VS Code open, but I am in the debug panel. I am not in the editor where I used to be in the Explorer. I am in the debug panel, and I have already created a launch file here for the build and debug an active file action. And as a result, I have created this JSON file where the only thing that I had to change was that I turned external console to be true. This worked for me on Mac OS, but please follow the instructions for debugging that are posted on our Canvas website. But basically, when we go back here to our file and when we launch the debugger, all our interactions with the program will be here in this external terminal. But then here in VS Code, we will see our local variables. We will see our breakpoints, for example. Oh, wait, what is a breakpoint? Well, in order for us to go step by step through our program, we must have a breakpoint. Basically, we must have a line, a statement, where the program execution stops and allows us from there to go through the program line by line. I like to put my breakpoints at the very beginning, at least one, so I can start at the very beginning and go through the program from the beginning to the end. But later in the semester, as your programs will get bigger, you might move your breakpoint past the point where, let's say the first part, some part of the program already works fine. Then you can put your breakpoint after everything that you consider is working correctly. How do we set a breakpoint? I can put my mouse here on the left hand side of the line number, and wherever I will click, there will be a breakpoint. There it is. I put a breakpoint on line 8. If I want to remove it, I will just click on it again. But let's put a breakpoint on the first line and let's start running the program in debug mode. Okay, notice here that now is showing that I am running the program tax rate. These are the debug commands, the options for debugging. I can go from here and continue, which will basically run my program from this breakpoint to the end or to the next breakpoint. I can use step over, which will basically execute each line one by one. There's also step into, which we will use later when we write our own functions, step out, restart, or just simply stop debugging. We are going to use step over, and we will basically go through every statement one by one. So right now you can see our local variables here, which are basically every variable in our program. If you follow a little bit, if you try to look for every one of them, but right now they do not have initial values. They just have default values. Everything that is a numerical variable has the value 0, and marital status, which is a string, has a default value of an empty string. Note that they have not been initialized yet. They're just the debugger is telling us these are the variables of your program. Once I step over line 8, which means I execute line 8, we will see rate 1 will become 0.1. Let's do this. There we go. Oh, this is something that we learned about, right? Doubles don't have exact precision. So this number has not been exactly recorded at 0.1, but rather at 0.000000001. There's another little 1 at the end. That's why it's hard to say that two variables of type double are equal, because sometimes there might be a difference here at the very end. Let's do the same thing with rate 2. We're going to press again step over. Notice the breakpoint is behind us. It's not really interesting to us anymore, but there's this arrow here that basically shows what is the next line to be executed. So the next line, we're going to initialize rate 1 single limit to 32,000, rate 2 to 64,000, then tax 1 and tax 2 will be initialized as 0. And then we are going to the line where we are going to display a message for the user right here in this terminal. Please enter your income. And you will notice that I step over this line. I try to execute it, but nothing shows up. That's because all this text that it's about to be displayed for the user in the console, it's buffered. That means it's being stored in a location, character by character, until something tells the buffer, that's it, you've got enough, now spill your contents, and basically print them here in this window. Now, this happens if I have an end line directive or if cin is being executed. So once I'm going to press step over and this line will be executed, we will see the prompt, and basically the debugger will be waiting for us to enter a value for the income. There it is. Let's enter 10,000. Once we enter 10,000, execution returns here because cin has gotten its value, and income, the last variable modified here as it shows in this with this overlay square, has now become 10,000. Same thing for entering the marital status. Create a variable for it, execute, wait for it, let's say single, and then there we go, we're back here. Now the part that interests us today, since we are talking about nested branches, how will the flow of execution follow from here on? Once I have branches, once I have if and else statement, which lines out of these 24 will be executed? Not all of them, because we have just learned that that is the purpose of conditionals, of if statements, of branches, that not every line of code will be executed. Now let's take a look at it. Marital status, the value of this string is s. So the equality here will turn this statement true. If the condition is true, then the if block will be executed. That is this whole thing. Okay? We will see if it's exactly this whole thing. But what we mean to say that this will be executed means that from line 24, execution will jump to line 26. And when the program ends up at line 35, it will not execute the else. So we will just try to execute this block of statement, the if one. If the condition is true, we will try to execute this block of statement. If the condition is false, we will try to execute this block of statements. Let's try it. Right, so from 24 it went to 26. Now there's another condition. The income is 10,000. The single limit is 32,000. That means this statement is true as well. So execution will jump from line 26 to line 24. Once this is executed, else will not be executed. So let's see. From 26 to 24, from 26 to 28, and then after 28, it will jump over else and arrive at 35. Once it closes this curly brace, there is nothing to do with the else because we executed the if, because this statement was true. And we find ourselves after the if-else branching. And now we can compute the total tax, which is $1,000. And now executing this will display it right away because there's an end line character here. Once you end up to the return statement at the very end of main, just click continue and you will basically finish the program. Once it finishes, there's no record of anything here. This one basically says process completed. Everything was done with this program. These are the lines that were part of the program output. Let's try this again with different values. We can do it. It's allowed. New terminal window. Back to the breakpoint. Let's step through the constant declarations. Initializing tax 1 and tax 2. Please enter your income. Let's do 50,000. And let's do single again. This time, the status is single. We will still try to execute the statements in the if block, but let's see what happens. The income, 50,000, is higher than 32,000, right? So from here, since this condition is false, the next line to be executed will be inside the else, right here. Tax 1 computed, tax 2 computed. If branch is now over, and we will once again jump over and display the tax. One more time. New values. Initialize variables. Ask the user for income. Let's say $100,000. And then for marital status, we are going to enter married this time. Now, the condition here for the if statement is false. The entire if block is skipped and execution will go to the first line of the else statement. There it is, line 38. This new condition is now evaluated. The income is 100,000. The limit 64,000. So this is false as well. Execution will jump at the first statement in the else program. Compute tax 1, compute tax 2, get out of the if-else block, compute the total tax, and print out. We will do more examples with debugging, but for the moment, thank you for your attention.